Hello, I'm going to demonstrate executing a zero coupon bond contract using the Marlowe CLI tool in the Marlowe Starter Kit. So we have three examples of running a zero coupon bond contract in Marlowe. Two of them use Marlowe runtime, either at the command line or via a REST API. But you can also do that with lower level tools, and that's what we'll take a look at right now. As in the previous tutorials, we have a instance of Jupyter Lab running, and we have some notebooks. So we're going to look at the third notebook here. This is the same contract as the first one. It's an address-based contract that lends principal and then returns principal plus interest. So nothing new there. We're going to clear the output, so we have a fresh start here. And once again, we have to go through preliminaries. Now, in this case, we don't need Marlowe runtime. We just need a connection to the node socket. So we have that. We also have the signing keys and address for the borrower and the lender. We'll connect several environment variables. So we have these. We found the node socket, and the network magic is one. That's the pre-production network. We'll take a look at the addresses and keys. So we have an address for the lender. They have 1,000 ADA in their wallet. And then there's a link to the Cardano Scan Explorer where we can take a look at that wallet. We're not going to do that right now. Then the borrower also has an address. They also have funds in their wallet. And we could go to the Explorer and look at theirs also. Contract design is the same as before. It's going to have 80 ADA of principal and 5 ADA of interest. And we're going to start the contract off with 2 ADA at the contract address to satisfy the minimum ADA or the minimum UTXO protocol requirement. As previously, we have some time calculations to do. So here's the start time, either in human readable form or machine readable form. And there are 2 deadlines in this contract. The first is the deadline for the lender to deposit the principal, and the second is for the borrower to return the principal and deposit the interest. As previously, we're going to use the Marlowe CLI template to create this contract, and you can get help for all the options in that. It has a number of contracts. We could have used the Marlowe Playground to design the contract also. So we'll take a quick peek at the contract itself. Here it is. This is in YAML format. The file is JSON, but we're converting it to make it easier to read. You can see the various blocks in the contract here. And then, as we showed in the first tutorial, it's always good to check the viability of a contract if you ever intend to run it on mainnet. So there are things you need to understand, some guides to read, experiment in the playground with it to make sure you really understand what's going on and it matches your intention. We have an analysis tool that will study the safety of the contract. And then, of course, we have the Cardano test nets where you can actually run the contract in an environment very, very similar to mainnet. So we're not using Marlowe runtime here. We're using the Marlowe CLI tool, and it has a run command that has a number of subcommands we're going to use. So the first thing is the initialize command. This basically gathers information about the contract file we just created, and the initial state file. And if you want to stake the ADA at the Marlowe validator, it has an option for that. And then if you're using a reference script, options for how to find the reference script. And if the contract has roles in it, which this one doesn't, you specify the roles currency. So this really bundles all the information together to get you started. We're going to initialize that. So now we have it initialized. And we're going to be using a command called auto execute. This basically creates and runs a transaction, and it has a number of options here, but basically it's taking the information about the Marlowe state, which is embodied in the Plutus datum, before and after the transaction, and it's setting up a transaction that makes that transition from before to after. And we'll see the details of that here. So we're starting with basically step one. So this bundle of information about the contract. The lender is going to be creating the contract. They need to sign. We're going to store the signed transaction in a file. We're going to wait 600 seconds for it to be confirmed on the blockchain. And we're going to print a few statistics just so we can see what's going on. So there we go. So it's been submitted to the node. And this is a non-Plutus transaction, so the statistics are a little bit boring here. There's no Plutus memory used, and the transaction is quite small. It has a modest fee. And so that's the creation transaction. Just wait for it to be confirmed. Okay, so there it is. We can go visit it on an Explorer. We can actually look at the two ADA at the script address. There's the hash of the datum that is the state. And because we actually went through exploring things on a Cardano Explorer in the first two lectures, I'm not going to visit that at every step here. The lender now has to deposit. So they have to deposit their 80 ADA. And we have a command here called prepare. And this lets you basically take action on a Marlowe contract. So you can make any number of deposits, choices, and notifications. And not just one of them, you could make several deposits in a row if you wanted, if the contract rules allowed that. And then you have to give it some time constraints on when the transaction has to be submitted. This is very similar to Cardano CLI, where you have invalid before and invalid hereafter parameters. So for this contract, the lender is depositing into their internal account, and they're depositing the principal. And then we're going to give it a time window of about 6 minutes so that the node has time to confirm things. And the Marlowe file we created originally for the first transaction was Marlowe 1, so we're starting from that. And then we're making a transition to this file Marlowe 2. And so these files basically track what's going on step by step in the contract. You may know that the Marlowe interpreter is a state machine. These are the state information files for those transitions. So we're going to do prepare, and it tells us a little bit of information. It did some rounding off of time. It tells us the contract is going to be making that payment into the borrower, so it's going to the borrower address. So you get to see a little bit of what's going on. Now we're going to execute the transaction, and this time it's a little different because we're not in the creation situation where there was no previous state. Now we have a previous state, and so we have to include that in the execution. So we start with that prior state and we go to the subsequent state. The lender is receiving the change from the transaction. They're signing the transaction. And we also have to tell the tool, well, where is this Marlowe contract? So the previous transaction was TX1, and it was at the first index of that transaction. So when we execute this, it will move the contract forward. And now we see, because this is a Plutus transaction, we're actually using some of the memory and some of the steps. The transaction is a little bit bigger, it's a little more costly. And so we'll wait here and see when it's confirmed. Okay, there it is. And there's the link. And then we'll take a look at that in a minute, but I'll show you just at the command line. we can see the borrower is about 82 ADA down. The lender is 82 down. The borrower has received the 80 ADA, and the contract is still alive at the contract address. So they have the 2 ADA there at the address. Now, the interesting thing is we don't have a tool to view the contract without using Marlowe runtime. So or really the only thing you could do would be to look in these state files. You can also look on the chain. Down the road, there'll be a Marlowe Explorer where you can look on chain for things. So it hasn't percolated through to the Cardano Explorer yet, so we'll just wait a second for that. There it is. And this is exactly what we saw in the first lecture. There's a transition from the contract to the contract. It's holding 2 ADA. If you actually poked around in this, you could see the datum has changed. And there are inspection tools, so you could actually even try to look at the datum. It's in a CBOR format, so it's not very friendly to humans, but with a little practice, you can even understand that. And basically, we took in the ADA and we paid out an extra 80 to the address of the borrower. Okay, so now the borrower repays the loan. This is really identical to what we did before. It's just another deposit, except we're depositing principal and interest. And so we actually have 2 payments that are going to occur here. The lender gets the principal and interest, which is 85 ADA, and they also get their initial 2 ADA deposit that they put when they created the contract. So total, they're going to receive 87 ADA back. And then the execution transaction is very much the same. We're going from step 2 to 3. The borrower is signing things and getting the change here, and we'll just submit that. This Plutus transaction is a little bit cheaper than the previous one. It actually confirmed really fast. We'll be able to take a look at it in a minute. You can see the 87 ADA has been received by the lender. And the borrower, if you add this up, you'll see that they're down approximately the 5 ADA that they had contributed as interest. So let's see this on the blockchain. We'll have to wait a little bit. There's the transaction. And this closes the contract. So we've consumed the 2 ADA at the contract address. There's no output to the contract. The borrower gets their change, and the lender gets their 87 ADA. So if we click here, we should see the lender. They're about 5 ADA. There's some fees they paid up. That's the interest. And then the borrower, if you take a look here, they're about 5 ADA down. So that's basically the contract. This is running it without the Marlowe runtime, so you've got to keep track of all the UTXOs yourself. The runtime is not there to do that for you. Thank you.